That way, if anyone's missing. All right. So last time we introduced how to calculate density. If you remember, we defined it as the mass of something over its volume. So this document, I said, included stuff that we would have normally done in school. Obviously, we're not in school, so we're gonna have to maybe eliminate or ignore some of these things. The first part here is just how to use a triple beam balance, which is a type of scale, how to read it. So I'm going to skip over this. But this might be interesting here. This is something called displacement method. This is actually how to get volume. I think we mentioned this last time. So if you recall, density as review is defined as mass over volume, right? So if the volume is like from an object that has an irregular shape, like this is irregular, which means you're not going to be able really to calculate it with a formula. You could use something like the displacement method, which the way it works is you have a certain amount of water and you basically measure that amount first. So like, for example, here it looks like there's about 150 milliliters of water. And then we drop the rock in, and you'll notice that the volume changes to about, this is about 180, because every one of these long lines is 10 milliliters. So that would be 160, that would be 170, that would be about 180. So the displacement method is the difference in volume would be the volume of the object. So we could say in this case, the volume of the rock is 30 milliliters, all right? The reason why I mentioned this is because, it might come up in your problem set. So you should know, if you come across the word displacement, realize that the difference in volume is the volume of the object. And I think this may be the example I showed you last time. Here we can see that the volume is about 30 milliliters, and then we put some object in, now it's about 35. So this says that the volume of the rock has to be 5 milliliters. It would be the difference between those two values, okay? Very, very easy concept. Here's another one. This is the one we talked about last time. The original volume is 20 milliliters without the rock. Then it's about 30 and a half. So we could say the difference, 10 and a half, is the volume of the rock. Okay. So last time we introduced density. If you remember, the formula is quite easy. It's mass over volume. So we did a question like this one. What's the density of an object that has a mass of 1,100 grams? And in this case, we had to work out the volume, if you remember, right? Because this is an object that is basically a cube, 10 by 4 by 5. So we worked out the volume, 200 centimeters cubed. And remember, density is just simply the mass over the volume, right? So its mass, 1,100 grams over its volume of 200 centimeters cubed. So the expectation is that, you might be asked to calculate the density, which is the mass over volume, or possibly the mass, which is the density times the volume, or possibly the volume, which will be the mass over the density. If you remember, that was all simplified in this magic triangle, right? So those are the three expectations, the three types of equations that you might have to do, okay? So what we're going to do, we'll just do one more review question, and then I'm going to show you maybe some more challenging questions, So this is what was assigned last time. These are practice questions. These are the answers. So we can actually maybe, for example, take up, a question like number 4 as a way to review, right? So for example, number 4 says, what will the mass of mercury be if you fill a 10-liter container? Now, remember, mercury is actually a liquid. It's the only metal that's actually a liquid. So if it fills a 10-liter container, that means that its volume is 10 liters. So what would the density be of mercury? Okay, well, the density of mercury is its mass over its volume. So the mass, so we're looking for mass here in this question. So we're looking for mass. So we're looking for the mass, which is going to be the density times the volume. This is what mass of mercury. Okay, so the density is 13.6 kilograms per liter times 10 liters. So that would give you a mass, I'm sorry, just disappeared on you. It would give you a mass of 136 kilograms. Okay, so that's number 4. We can look at a question like number 5, where number 5, you're being asked to calculate the density. So in this case, we have the mass of the aluminum and we have its volume. So let me put the answer, let me work it out maybe over here, a bit of space over here, okay? So the density would be its mass over its volume. Its mass is 500 grams. Its volume is 185.2 centimeters cubed. Okay, so if we get our calculator out, 500 divided by 182.5, was it 182.5? Nope, 185.2. 185.2. We get a density of about 2 point, I'm gonna round it up to about 2.7. 2.7 what? Well, it's gonna be 2.7 grams per centimeter cubed. Okay. Now, there was one question that I've actually even wrote specifically. What is the, it's a challenge, right? What is the density in kilograms per meters cubed? So I don't want to go over that question because actually we're going to do that question or type of question today, okay? So if you had trouble with that question, after today's lesson, see if you can go back and maybe figure out the answer and how, you know, how we got the answer for C, all right? So we're going to do a question like that in, where is it? I thought we were doing, aren't we doing a question like that? I thought we were doing a question like that. Okay, we're doing a question like that here. Yeah, okay. So let's do number 1. Number 1 is kind of similar to that question. Kind of. All right. It says, what is, actually, it's not similar at all. So you know what? Here's what we're going to do. We are just going to do number 7. Let's just do number 7, okay? I thought we had a question like that, but apparently we don't. Okay, I must be thinking of your problem set then, where you have to do something like this. Okay, so let's do number 7, all right? We're going to do the density. Sorry, it says the density is 19.3 grams per centimeters cubed. We're going to figure out the mass of the gold bar. Okay, we're going to work out the mass. So we'll do number 7. So we know mass is density times volume. Okay, we have the density, but we don't have the volume, right? We know the density is 19.3 grams per centimeters cubed, but we don't know what the volume is. So we're gonna figure that part out. Now, we are told that it's a bar, so we can assume that it kind of looks like this. Okay, so it's gonna have a width, it's gonna have a height, it's gonna have a length, it's gonna have those 3 dimensions. So we can work out the volume as length times width times height. So we're told that it's 20 centimeters by 10 centimeters by 5 centimeters. So that works out to 1,000 centimeters cubed. Okay, so that would be the volume. So the mass then would be the density, 19.3 grams per centimeter cubed, times the volume, which is 1,000 centimeters cubed. You can see that these two would cancel out. So then its mass would be, move the decimal over three spots. So it was here. Now we're going to move it 1, 2, 3. So it's going to be 19,390 grams. Okay. Now, I'm going to skip B. I'm going to go to C. So C is, what is this density in kilograms per meters cubed? So what we're going to do is we're going to change the density into grams per centimeter cubed into kilograms per meter cubed. Pay attention to this one because this actually comes up in your problem set, okay? So here we go. Now, if you recall when we did the section on space, when we did equations and we solved for things, I never really introduced any actual equations. The way we solved those questions was to use ratios, right? So we can actually do the same thing here. For instance, we could say the density of gold is 19.3 grams for every 1 centimeter cubed, okay? And what we're going to do is we're going to convert that into kilograms per meter cubed by looking at them separately. So here's what we're going to do. I'm going to first change the mass, okay? So here's what we know. We know it's 19.3 grams. We want to convert that to kilograms. So let's say I set up a ratio where I want to try to figure out what this value is in kilograms. So I'm going to put grams on top. I'm going to put kilograms on the bottom. I know that, so just to reiterate, I'm going to put grams on top and put kilograms in the bottom, okay? Here's what I know. If I Google how many grams in a kilogram, it comes up that there are 1,000 grams in 1 kilogram. So that's the ratio, okay? It's 19.3 over x equals 1,000 over 1. All right, if you remember, you could actually just flip those two values or two sides. You can just flip them upside down and do kilograms over grams. So that would give you then x over 19.3 grams equals 1 over 1,000. So 1 kilogram over 1,000 grams. I forgot to put the unit in here, okay? Grams, kilograms. So if you remember what you do, you cross out because we're dividing, and then you multiply on the other side, right? Now this should be familiar because we did this in space. Same technique, right? And you'll notice that grams cancel out, and you're left with kilograms. And you know, this is 19.3 times 1, which is easy, 19.3, divided by 1,000. So x would equal 0.0193 kilograms. Okay? Now, we can do the exact same thing with the denominator, which is in centimeters cubed. We can change that. So that's what we're going to do, right? We're going to change that to meters cubed. So we are going to look for meters cubed. So let's say that we say this 1 meter cubed, okay, would be what? Well, okay, well, let's think about a meter. So a meter cubed would be 1 meter by 1 meter by 1 meter. It will look something like this, right? So it'll be 1 meter by 1 meter by 1 meter. Now, I can change that to centimeters because I know that 1 meter is equal to 100 centimeters, okay? So in other words, a cube that's 1 meter by 1 meter by 1 meter would also be 100 centimeters by 100 centimeters by 100 centimeters. So we could say then that 1 meter cubed would be the same as 100 times 100 times 100, which is 1 million. It's 1 million centimeters cubed. Okay. All right, so that's our ratio, 1 meter cubed over 1 million centimeters cubed. Okay, so what are we trying to figure out? Well, if I look at my formula for density, the density we know is mass over volume. So the density of gold is 19.3 grams for every 1 centimeter cubed, right? Because saying per centimeter cubed is exactly the same as saying for every 1 centimeter cubed. So if I want to change that 1 centimeter cubed into meters cubed, I can do the same thing as I did before. I want to know how many meters cubed is 1 centimeter cubed. Okay, so what could I do? Well, I can get rid of this 1 centimeter cubed and multiply this side by 1 centimeters cubed. And now my centimeters cubed will cancel out. So X would be 1 meter cubed over a million. So X is 1 over a million. Now, if I do 1 divided by a million, there's a million. I can write it as this, 0.0000, what? How many zeros did I just say there? It should be 5 zeros and a 1. So I can write it like that. Okay. Or the other way, if you want, you can write it as 1 times 10 to the minus 6 meters cubed. I really don't care how you write it, okay? They're both the same thing. And the reason, if you remember, is because we move the decimal 6, 1, 2, 3, 4, 5, 6 to the right. So that would make it 10 to the negative 6. If you don't remember that, not a big deal, okay? Okay, so here's what we know now. We know the mass, we converted it from 19.3 grams into kilograms, which is right over here. And now we just converted the centimeters cubed into meters cubed, which is over here. So now what I can do is just simply express it as mass over volume again, right? I can now say density is mass over volume, 0.0193 kilograms over 0.000001 meters cubed. Okay, so what does that give us? All right, well, 0.0193 divided by 0.0000, it's 5 zeros, 1, is equal to 19,300, okay? So 19,300 kilograms for every meter cubed. All right. Now, if you compare it to the original density, you'll notice something. Nothing like the number, it's like, you should see the number is the same, 193, right? So that looks the same. What's different is the increase in magnitude. So 19.3 grams per centimeter cube is the same as 19,300 kilograms per meter cube. So it seems like if you're going from grams to centimeters cube into kilogram to meter cube, that the value would increase by 1,000. You would then assume that the reverse is true, that if we go the other way, would we be dividing by 1,000? Okay. So if I have, for example, 5 grams per centimeter cube, and I want to express that into kilograms per meter cube, then that would be 5,000 kilograms per meter cubed. All right. So now that we've gone over that, if you come across a question like that in your problem set, you know what to do. If you forgot, I'm recording this, so just come back to this video clip, and this will hopefully help you out. Okay. So let's look at 3 questions, because that was a little bit challenging. Let's look at 3 other questions that might be also a little bit challenging. So here's the first one. What is the mass of gold if you had 0.1 meter cubed of it and its density was 19.3 grams per milliliter? Okay. So here's what we can do. If you remember, you might not remember it, and that's okay. 1 milliliter is the same as a cubic centimeter. So what we could say is that 19.3 grams per milliliter is the same as 19.3 grams per centimeter cubed. Okay, it's the same thing. Now, the volume of this gold bar, or whatever it is, its volume is 0.1 meters cubed. Okay. Now, if you remember from the previous ratio, 1 meter cubed is equivalent to 1,000,000 centimeters cubed. So if I want to convert that, I could say, well, 1 meter cubed is equal to 1,000,000 centimeters cubed. So then how many centimeters cubed would 0.1 be? Okay, how many centimeters cubed would 0.1 be? If we solve for that, then x would end up being 100,000 centimeters cubed. Okay. So now we have the volume. So now what we can do is just simply solve for the mass. Because if you have the volume, remember the mass is the density times the volume. So the density is 19.3 grams per centimeters cubed. Okay. And the volume is 100,000 centimeters cubed. So that would give you, should be 1,930,000 grams. All right, that's what it should be. Yeah, it's 1,930,000 grams. Okay, so I guess what would be a little bit challenging in this question is that we can't just do m equals d times v directly, because if I look at the density is in grams per centimeters cubed, but the volume is in meters cubed. So you have to make sure that the units are the same. If they're not the same, you have to convert them. It's very, 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 very important. Okay? So let's look at the next question. Next question is way different than something that you've seen. So this is really, really different. I'm going to show you a technique that you can use because you are going to come across this question in the problem set. If you remember, an alloy is when you have 2 or more metals. Not necessarily, they don't have to all be metals, but usually they're metals that are in solution. So like bronze, for example, would be an alloy from copper and tin. All right. Now, let's assume that this is a bronze alloy made of copper and tin, and that it's about 88% copper and 12% tin. Now, what we're going to do is we're going to find its density based on the fact that it's part copper, part tin. Okay. So this is how you would do it. You would say that the density of one of the materials, let's say we call copper, we'll call that material A, and we'll say tin is material B. okay? So what we can say is the density of the alloy, so I'm gonna write D alloy, would actually be the sum of the two densities of copper and tin, but you have to take into account the fact that it's 88% copper and 12% tin. So this is how you would write it. You would say the density of the alloy would be the density of substance A, okay, times the amount of A. I'm going to show you what this means, all right? Plus the density of substance B times the amount of B, okay? Now, we have in this question density of each metal. So it says that copper is 8.96 grams per centimeters cubed. Now, the amount of copper is 88%. So the only thing that you might forget is when we have the amount, we want the amount not in percent. So don't do it in percent. We're going to do it as a value expressed over 1. So in other words, 88% would be 0.88. Okay. 12% would then be 0.12. All right. So 88% is 0.88, 12% is 0.12. The reason why we're doing that is because these two numbers have to add up to 1. Okay. So when we add them up, they're going to add up to 1. So it's the density of copper times the amount of copper, 88%, but we're not writing it as a percent, we're writing it as a number out of 1, plus the density of tin times the amount of tin, got to put my unit in, which is 0.12. Okay, so if we do that, so 8.96 times 0.88 is, we'll just say 7.88. So this is 7.88 grams per centimeter cubed. And then the other one is 7.31 times 0.12. 7.31 times 0.12. And that is, let's say 0.88. So this is 0.88 grams per centimeter cubed. Now we could say that the density of the alloy, we have to write that down, let's say dalloy. The density of the alloy would be the sum of these two. So it would be 0.88 plus 7.88, which would be 8.76. Okay, I think, was there a question, I think, in the chat? No, it doesn't matter that, no, 0.88 doesn't have a unit because it's the amount. Like it would basically be, I think you guys did this in elementary school, where you can express percentages as values over 1, like 50% would be 0.5, 25% would be 0.25. So they don't have units. No, they don't have units. It's a good question. There is no unit. Okay, so that's the formula. So you can see what it is. It's the sum of the density of one of the metals times the amount of the metal, but not as a percent, times the density of the other times the amount of the other, right? And then you just add those two up. And that would be the density of your alloy. And by the way, I mean, not that I asked you this in the problem set, but if your alloy was made up of 3 metals, let's say it was A, B, and C, then you would just simply add the density times the amount of the third metal. So it would be D times A plus D times B plus D times C, and so on and so forth, okay? Now, if I look at number three is actually the opposite of number two. What if we have something like brass, which is made up of copper and zinc? Okay, it's an alloy. So brass is made up of copper and zinc. And we have its density, but we don't know its percentage. So what do we do in this case? Okay, well, we can use the exact same formula we just used, right? We could say the density of my alloy is the density of A times the amount of A plus the density of B times the amount for B. Okay, so we could do this. Now, so let's start setting it up the same way. But in this case, obviously, what's different is we have the density of the alloy. So we're going to write that down. The density of the alloy is 8.73 grams per centimeters cubed. Okay. Now, we have the density for A. So let's go again with copper being A, and we'll say zinc is B. Okay. So we have the density for copper, 8.96 grams per centimeter cubed times A, all right, plus the density for B, which is 7.14 grams per centimeter cubed times B. Okay, now, so we come to a problem though, because we have two unknowns. We don't know what A is, we don't know what B is. But here's what we do know. So this is, I'm going to show you something that some of you may have seen. I don't know if you learned this in grade 9. I think you do learn this in grade 9, but I can't be 100% sure. I know for sure you learned it in grade 10, but you may have already learned it. If you did it, I'm going to show it to you right now, okay? So we have two unknowns, right? We have A and B, but here's what we know about A and B. We know that A and B have to add up to 1, right? We know they have to add up to 1. If you look at the previous example, 88% copper was 0.88, and 12% tin was 0.12, and that adds up to 1, right? So we know it has to add up to 1. 1 meaning just the entire amount of the alloy. So what I could do is this. I could say if A plus B is equal to 1, then what's true is B would equal A minus 1. I can move the A to the other side. Right now, the A is positive. If I move it to the other side, it becomes negative. Okay, so this is true. B is also a 1 minus A. Now, why am I doing this? Because what we can do is we could reduce the equation to one variable by doing this now. So we know 8.73 grams per centimeter cubed is the sum of dA times A. Okay, so I'm going to leave that as 8.96 grams per centimeter cubed times A. Okay, all right, plus 7.14 grams per centimeter cubed. But instead of writing times B, what I'm going to do is I'm going to substitute. Because I wrote over here that B is the same as 1 minus A. So instead of writing B, I'm going to write 1 minus A. Okay? Now, by doing that, you'll notice that we only have one unknown in my equation. And it's only the letter A. There's no two unknowns anymore, just one. Okay? Just one unknown. So now what we can do is we can expand it out. But what I'm going to do, because you'll notice, I'm going to just make this a little bit cleaner so you could see it really nicely. I'm just going to eliminate the units, because we don't need them, because we're just looking for the amount. So we're just looking for like, what is A? So I'm actually going to get rid of the units because we don't need them, okay? All right, so 8.73 is equal to 8.96 times A. So I'm just going to write that as 8.96 A. All right. Plus, okay, so how do you expand this? Well, you multiply the number outside the bracket by everything inside the bracket. So 7.14 times 1. That's just 7.14. And then 7.14 times the next value, which is negative A. So that's going to be negative 7.14 A. Okay. So now let's collect the like terms. All right. Let's collect the like terms. So we have 8.73 is equal to, I'm going to add these two up because they both have A, right? So 8.96A minus 7.14A would be positive 1.82A. Okay? Plus 7.14. So I combine these two. All right. Now, I'm going to move the 7.14 to the other side. All right. So I'm going to move it to the other side. So I'm going to get rid of it. I'm going to move it to the other side. So right now, as you know, it says positive. So I'm going to move it to the other side, and it's going to become negative. All right. So I'm going to squeeze it in over here, right? So if I move this to the other side, it's going to become 8.73 minus 7.14. This is positive on one side, bring to the other side becomes negative, right? Is equal to 1.2A. All right, so 8.73 minus 7.14, so 8.73 minus 1.74. Is that 1.74? Nope, 7.14 minus 7.14 equals 1.59. I should have known that. Okay, so that's 1.59 equals 1.28. Now, I'm going to get rid of the 1.2. So 1.2A is the same as 1.2 times A. So how do you get rid of something? You just do the opposite on the other side. So if this is 1.2A, so 1.2 times A, to get rid of it, I have to divide by 1.2 on the other side. So what does that give you? That says that A would be 1.59 divided by 1.82. 0.59 divided by 1.82. So that will give you 0.87. So A is 0.87. All right. What's A? Now, the way we set it up, A is copper. So copper is 87%. Now, we can then figure out what B is, because we said B is 1 minus A. So we could say then B would be 1 minus 0.87. So that would be 0.83. You'll notice these two numbers add up to 1, right? So copper is 87%, zinc is about 13%. All right, so you notice that this question is exactly the opposite of the previous question. So what I have for you is I have a few questions that are kind of challenging like this, all right? They're very similar to the ones we just did. So try them out. The answers are there, so you can take a look. And what I've done is I've put out a problem set, okay? So take your time on this. I know that this might not be easy. You might have to review this video You might have to ask questions the next time we meet on density. Some of you might find it really easy. So what I did was I posted 10 questions. Okay, some are very easy, some are more challenging. Okay, some require, what we just talked about today. Some are very straightforward. So there's 10 questions. Just when you answer them, just submit them back into this folder. Okay. All right. Okay. So I think that is it. All right, girls. So I'm going to stop recording, take any questions.